Okay, in this video we're going to do a quick review of metric system, or SI system, as we use in science. In the metric system we have several base units. Our base units are going to be, that we're going to use most commonly at the beginning here, are the units of length, the meter, the unit of time, the second, the unit of mass being the gram. There are others. We're not going to worry with those right now. We'll introduce them as we get to them. But let's focus on our length and mass measurements. If I was going to measure the length of a piece of paper, and I've got a meter stick, that meter stick is probably, the length of meter is probably not the ideal unit of measure that I would want. So I have meter. I can put in front of that the prefix centi, which is going to make this a smaller unit, something closer to the size of the piece of paper. Same thing with gram. Let's say that I wanted to weigh a car. I wouldn't want to use the mass gram. I would put a K in front of it to make it kilograms. Something that's going to be not as cumbersome to use. The prefixes that we're going to use are centi, milli, micro, and kilo. So centi means 1/100th. So that's going to reduce the base unit or make it a smaller unit by 1/100th. An example would be 100 centimeters is equal to 1 meter. Milli is 1/1000th. That's going to reduce the base unit by 1,000. So 1,000 millimeters would equal 1 meter. Micro is going to be 1/1,000,000th, and going to change it by a million. I'll use scientific notation here so I have some room. 10 to the 6th micrometers is going to equal 1 meter. Now kilo is the only one of this group that is going to make the unit bigger. So if I put the unit of kilo, or prefix of kilo, that means 1,000. So 1 kilogram would equal 1,000 grams. So you see that I've got the base units of centi, milli, and micro. They're less than the base unit. The prefix of kilo is bigger than the base unit. Since we only have a certain number of base units, we have what we call derived units. Now derived units come from our base units. Our base units for length, as a reminder, we got length measured in meters, we've got mass measured in grams, and we've got time measured in seconds. Now we can use these units to make up new measurements that are combinations of these. For example, speed is equal to length divided by time. So if we use our base units, we would have the meter divided by the second. So that would be a unit of speed as a derived unit coming from the base units of length and time. We have density, which you're going to do in the lab. We have density is a mass divided by a length times another length times another length. And we're getting this to give us our volume. So volume is a derived unit coming from the unit of length, where you multiply that 3 times. Now if I'm going to use a centimeter as here, because we're going to use smaller measurements. But if I have centimeter times centimeter times centimeter, that is going to give me centimeters cubed, and that is our volume measurement. You could have meters cubed, you could have other things, but as long as it's cubed, it's a volume measurement. That volume measurement is coming from the base unit of length, and therefore volume is a derived unit. Density then is a derived unit from mass, and the derived unit from volume.